Feedback amplifier. An op-amp that was a feedback is called as a feedback amplifier. Feedback amplifier is sometimes referred as a closed loop amplifier because the feedback forms a closed loop between input and output. A closed loop amplifier can be represented by using two blocks, one of an op-amp and another one is upon one of an op-amp and another for a feedback circuit. So there are four ways to connect these two blocks: voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So this is the diagram for the voltage series feedback amplifier and voltage series feedback amplifier, to which we use which both diagram represents with an op amp. The difference voltage is equal to the input voltage minus the F by frequency by the B volt. The feedback volt always opposes the input voltage. Hence, the feedback is said to be negative. It will perform by computing closed loop voltage gain, input and output resistance, and bandwidth. Closed loop voltage gain. The closed loop voltage gain is an AF is equal to V output divided by V input. What V output is equal to A, V, I, D is equal to A, voltage 1 minus voltage 2. A is last signal when compared to the voltage gain. So input resistance with the feedback. From the below circuits, RA is greater than the input resistance. RAF is greater than the input resistance of an op amp with the feedback derivation of an input resistance with feedback. Bandwidth feedback. The bandwidth feedback amplifier is defined as the band of a range frequency for which gains remains constant. For an op amp with a single break frequency, the gain bandwidth product is constant and equal. A is equal to open loop voltage gain. F0 is denoted as a break frequency. AF is closed loop voltage gain. FF is the bandwidth and the feedback. FF denotes that the AF0 divided by AF. For the non-inverting amplifier with the feedback, substitute the value of an AF in the and we get FF is equal to AF naught divided by A into 1 plus AB. So total output is said to be a voltage with a feedback output. Open loop, even a very small volt as the input and op amps can cause the reach maximum value, that is saturation voltage, because of its very high voltage gain. According to the equation for a gain output voltage circuits, V out is either plus V or a minus V. Conclusion of a non-inverting amplifier with a feedback. The clear of the characteristic of the perfect voltage and it has a input resistance. Total output offset of V out with the feedback is equal to total output offset voltage without feedback. So V out is equal to plus VER minus EV saturation voltage. Voltage follower non-inverting buffer. The lowest gain that can be obtained from a non-inverting amplifier feedback is 1. When the non-inverting amplifier is designed for the unity, and it is called as the voltage follower because the voltage output voltage is equal to and in phase with an input or in volt follower. It is similar to discrete emitter follower. The volt follower is preferred because it has much higher input resistance and the output amplitude is exactly equal to input. In this figure, all the output voltage is fed back into the inverting terminal of the circuits. V out is equal to plus or minus V saturation minus A. This is the diagram which shows the saturation voltage. So where V input is there, op amp which is connected with an plus VCC and minus VE, and it is connected series with an resistive load. Thank you.